2 kilogram ball is traveling at 5 meters per second, strikes a 1 kilogram ball traveling at -8 meters per second. After the collision, the 2 kilogram ball is directed with a new velocity of 30 degrees of its initial direction. What is the y component of the velocity of the 2 kilogram ball after the collision? So right here we have a picture of a 2 kilogram ball before the collision traveling 5 meters per second, and the 1 kilogram at -8 meters per second. And after, we see that this one is 30 degrees off, and then this one is 60 degrees. So if we see the components of the 2 kilogram ball, we have V1F cosine of 30, and we have V1Fy equal V1F sine of 30. And then we have the same thing for the 1 kilogram ball with a different angle. So now we have to find the velocity of the ball. We have to find the final velocities because it's not given to us, so we have to find that first. And we're going to use momentum initial equal momentum final. We have M1 V1 initial plus M2 V2 initial equals M1 V2 V1 final plus M2 V2 final. So if we plug in the quantities for here, we get 2 times 5 plus 1 kilogram -8. This is 2, and for this one, these are only traveling on the x-axis, so we would have these as x, and then this one would be V1F x cosine of 30 plus 1 times V negative V2 final cosine of 60. If we work that out, we get 10 plus -8, and we get, when you plug in 2 and the cosine of 30, we get 1.73 velocity initial final plus, and when we do cosine of 16 times 1, we get -0.5 V2 final. So we have 2 different velocities and we don't know them. So first, now we have to use, a momentum initial on the y plus momentum final on the y. That they're equal. So we have M1 V1 initial on the y plus M2 V2 initial on the y equals M1 V1 final on the y plus M2 V2 final on the y. So in the initial collision, there's no y, so this would go to 0 and this would go to 0. So we have 0 equals M1, and then we have VFY. VFY would be V1F sine of 30 plus M2, which is 1, times negative V2F sine of 60. If we solve for this, this would be 2. We would have 0 equals V1F because sine of 30 is half, and times 2, that's 1, minus, and the sine of 60 is 0.86 V2F. So we solve for V1F, and V1F is equal to 0.86 V2F. So now that we have this one, we can bring it back over here, and we can plug it in. So right here we would have 2 equals 1.73 V1F, and the V1F, we have that it's 0.86 V2F plus, or we can have it as a negative 0.5 V2F. When we do the math, this turns out 2 equals 1.5 V2F minus 0.5 V2F. So we have that V2F is equal to 2. So we have our velocity 2 final, and it wants a y component. So we have that velocity 1 Fy equals V1F sine of 30 degrees. V1F on the y equals V1F, we have it as 0.86. We have it, sorry, it's V1F is we're looking for V1F, so V1F equals 0.86 V2F. So V1F equals 0.86, and V2F, we have that it's 2. 0.86 times 2, and we have V1F equals 1.74 meters per second. And now we're trying to find the y component. This is the velocity, so we're trying to find the y component. So the y component is V1 Fy equals V1F sine of 30. So when we plug it in, we have 1.74 sine of 30. And we have that V1 F on the y equals 0.87 meters per second.